Hi there and welcome to another episode of PILOTCLIMB.com. In today's video we are going to see how can you handle an engine failure at V1 or slightly after V1. Anyway, an engine failure that will make you continue the takeoff with one engine inoperative. We're gonna go through a briefing now. We're gonna see what are the differences between a normal takeoff and a takeoff with one engine out, and then once we have done the briefing, once that everything is clear, we are going to fly the full procedure, okay, the full profile. So we are going to get to the rotation, we're gonna do the rotation, the initial climb, and then up to the level off. After that we level off with one engine operative and everything under control, we're gonna discuss the next course of action that a pilot and an airline pilot should take in order to land or continue to the destination, all the implication and consideration that you should perform. So without further ado, let's jump right into it. V1 rotate. Hi there, I'm Gabriele from PILOTCLIMB.com. I help you to become a better pilot. So if you need any help, whether you are a simmer or a professional pilot or a student pilot, go to PILOTCLIMB.com where you can check my services. Okay, so as we said, today's video we focused on how can you handle an engine out takeoff. So you accelerate, you arrived at V1, and then after V1 you have an engine failure. So you cannot stop the takeoff because you're already after V1. You need to continue. So how do you deal with that? What do you do? What are the differences between the V1 and between a takeoff with one engine operative and a takeoff with two engines? So first of all, guys, we need to understand the importance of having a good briefing before the takeoff and understand what you should do if in case you have an engine failure. Okay, so when you do the briefing to your colleague, make sure everything is okay regarding the procedure that you should take and should make if an engine failure occurs, especially where you're flying. So let's say you're taking off at V1, you have an engine failure. It is imperative that during the briefing you make sure what you want to do. So in this case, as you can see, guys, in here, this is a flight from, I'll show you in here, okay, this is a flight from Alghero to Olbia. We are in Sardinia, where I'm from, okay. So as you can see, the magenta line is the SID, is the departure, okay. The first thing is that when you have an engine failure, you don't want to follow the SID really, because it doesn't, maybe with one engine out performance you might not be able to comply with the restrictions, okay, with the altitude restrictions. So what are your options? So you mainly have two options. The first option is that you continue straight ahead if there is no terrain around, okay, and the second option, guys, is that you basically perform the emergency turn. Okay, the emergency turn is the one engine out SID, the one engine out departure. So it's a departure that you should follow in case you have a engine failure. Okay, so but this is a discussion for another topic. In today's video, let's say that we can actually continue straight ahead. So we just take off and we continue straight ahead. We continue on the 202 track. Okay, so we try to maintain this 202 track. Okay, so first of all, on the briefing we say, okay, in case of an engine failure, continue straight ahead on the 202 and we climb, in this case, to the 3000 feet. Normally you want to climb above MSA, okay, but because we have got the sea in front of us, 3000 feet should be fine for this flight. Alright, so the other things that I want to make sure that is clear to you guys is the importance of working as a team when you have a problem like that, when you have an engine failure. So when you have an engine failure, there is a pilot flying and a pilot monitoring that deals with the problem, and the pilot flying and pilot monitoring, it can be either the captain or the first officer. So it doesn't mean that the captain is always the pilot flying where you have an engine failure. Even the first officer can be the pilot flying, okay, because the last thing that you want to do is, in a complicated scenario where you get close to the VR, to the rotation, to have somebody just trying to take the control from the other guy and say I have control. So let's say the first officer is flying. If the engine failure happens and the first officer is flying, the first officer will keep flying, okay. Then if the performances of the first officer or the captain are not good enough, the other crew member can actually say I have control and take control of the plane, okay. But anyway, should be standard. So if the first officer is pilot flying or the captain is pilot flying, should continue flying, and the other guy or girl is the pilot monitoring, okay. Then after airborne, the captain can use his authority and his common sense to say, listen, I'd rather be pilot monitoring or rather be pilot flying, but it is imperative that during this rotation phases during these maneuvers, it's important to stay as we are. Okay, if I'm pilot monitoring, I stay pilot monitoring, and if I'm pilot flying, I stay pilot flying. Okay, so now guys, the first thing that we need to understand that is very important is the meaning, the importance of V1 and VR and V2. So these are speeds, and I made separate videos, guys, about this speed. But if you look in here, guys, in today's flights, okay, as you can see from outside, look, if you look outside, we've got some rain in there, and this is wet runway. Okay, so what I did, guys, I set up the wet runway conditions in here. You can see is wet. Okay, so what does it mean is that we've got these speeds are actually based on a wet runway. Thus, the V1 is 109 knots. What does it mean, V1, guys? Very quickly, and then I made a few videos about this, but anyway, very quickly, the V1 is the latest point throughout your takeoff where you can actually start the rejected takeoff maneuver. So let's say at 109 knots, okay, at 109 knots, you need to start the rejected takeoff if an engine failure occurs. Okay, if an engine failure happens, if an engine failure happens after the 109 knots, okay, or even slightly before, because you don't really want to wait until 109 knots to take the decision whether to continue or to stop the aircraft. If an engine failure happens after V1, you have to continue the takeoff. So let's say the engine failure will happen between 110 knots, 110 and 118, you have to continue. So if the engine failure happens at 110 knots, we will accelerate until the VR, the rotation, which is in this case 118 knots, with only one engine. Okay, so at the VR we rotate the plane, and then we accelerate to the V2. Guys, the V2, again, very quickly, is the takeoff safety speed. It's a takeoff speed that actually allows you to get the best rate of climb in case you have one engine in operative. And that's why the V2 should be the speed that you should aim to fly with one engine operative. Okay, but anyway, from V2 up to V2 plus 20, it's okay, but it's preferable to fly the V2. Okay, the V2 is really the speed, your target speed for the one engine out. Okay, if the speed is below the white bug, which is V2 plus 15, limit the bank angle to 15 degrees. So when you turn, you cannot bank more than 15 degrees. Okay, guys, so beautiful. Now we talked about the V1, now we talked about the VR, now we talked about the V2. So we know that. What we are going to do now, we are going to take off, and then I'll talk you through what are the differences between the all engine operative takeoff and the one engine operative takeoff. Okay, so guys, it is important to understand the flight phases. Now we are about to take off. Okay, let's say we have been clear for takeoff. So what I'm gonna do, the lights are on, I can actually do that. We put some lights in there, everything is fine. I can increase the light intensity in there. We've got flap 5, guys, start trim around 6 units, and then we've got the takeoff. Let's go through some performance. We've got zero fuel weight 43, gross weight of 50 tons, target altitude is going to be 3000. We've got 24k takeoff with 93.8, and you can see in there, okay, we're gonna do a flap 5 takeoff and the speed V1 109, VR 118, and V2 138. So we've got a 131. Yeah, 131 the V2 in there. So what we're going to do, we just basically accelerate to the VR, and then once we rotate, we aim for the 131. Okay. First thing, very important, guys, is that if you have an engine failure throughout your takeoff run, you maintain directional control with the rudder. Okay, because if you use your yoke, guys, and let me do this. Okay, should be, here we go. So guys, if you have an engine failure, guys, you don't want to fly like that. Okay, what's the problem with that? Is because you have an engine failure. Okay, you only have one engine ready, so your performances are low. Okay, you have the thrust is not great, and the last thing that you want is to do this. Why? Is because if you look from outside, guys, let me go from outside, you will see, guys, that if I use the control, look what happened, that the flight spoiler will extend in the wing. Look, so if you use the flight control, you're gonna have the yoke. In this case, you're gonna have the flight spoiler that will rise on the wing, creating extra drag. Okay, and when you have two engines, that's okay. Okay, I mean, it's not ideal, but it's okay. But with one engine, you really want to limit the drag to the minimum possible. That's why you actually correct the yaw moment created by the one engine out with the rudders. Okay, so you want to keep wing level with the rudder. You can use a little bit of control wheel, however, should not be too much. Okay, try to limit, use the less possible, because that really makes sure that your drag is low. Okay, so this is the first thing. So takeoff V1, engine failure, maintain the center line with the rudder. Then you get to the rotation and you rotate. You're gonna have a target pitch attitude of 12.5 degrees. Okay, it's not 15 degrees because in a normal engine, all engine operative takeoff, you're gonna have a 15 degrees pitch up target. However, on the one engine out, you're gonna have 12.5. So we're gonna pitch up to the 12.5. Okay, the rate of rotation is going to be between 1.5 to 2 degrees per second. So you start the rotation, you will see that your altitude should increase by 1.5 to 2 degrees per second, and then we climb. Okay, we get to the 12.5, we get to the 400 feet, guys. And at 400 feet, the pilot monitoring should call, the pilot flying should call for the roll mode. Okay, in this case, it's going to be heading select because we don't want to follow the magenta line. We don't want to follow the SID. And then we're going to identify the problem. We're going to identify the failure. Okay, and this is very important because at 400 feet, guys, don't worry, I'm going through what we're going to do, but then once we're gonna fly it, okay, we're gonna stop the sim and we're gonna discuss. Okay, at 400 feet, guys, the pilot monitor, let's call it in this case the first officer, will identify the failure. What does it mean? Is that he's gonna go through all the engine's indication, whether it's the engine number 1 or engine number 2. It's gonna go through the engine indication of the failed engine one by one. It's gonna read through them. So for example, let's say the engine number 2 has failed. It's gonna say engine number 2, we've got N1 rotation, AGT, positive AGT, we've got N2 rotation, fuel flow, oil pressure, and then it's gonna go down and it's gonna check if there is any overheat or any fire indication. Okay, so that's how you analyze what's the problem. You identify the failure, because if you have an engine flame out, you're gonna have a different engine indications compared to an engine severe damage. Okay, because the engine severe damage, guys, as you can already imagine, is a severe damage to the engine. Thus, you're gonna have one of these indications, whether it's the N1, the AGT, N2, the oil pressure, and so on, completely zero or even missing the information. That means that that specific part of the engine is not there anymore, or there is a sensor problem. Okay, however, with an engine flame out, you're gonna have all the indications, however they are low. Okay, because you have to imagine, guys, that this N1 is the spin, the engine, the N1 and N2 is basically the engine that is spinning, guys. So even though the engine is failed, okay, because you have air coming through the engine, you still are gonna have some rotations in there. Okay, and if it's suddenly you have a zero in the N1, that means that the engine is basically stopped, suddenly stopped. Okay, and that is a severe damage. Okay, but we talked about that later. So 400 feet, we identify the failure. We climb to the 1000 feet above aerodrome level. In this case, Alghero is 100 feet, so our 1000 feet above aerodrome level is going to be 1100 feet. I set in here. Here we go. So 1100 feet, guys, we climb to 1100 feet and we bug up. Okay, so what does it mean is that we're gonna accelerate to the flap up minimum maneuvering speed. Thus we're gonna pitch down, guys. This is very important because we're gonna prioritize the acceleration. So we're gonna pitch down, we're gonna accelerate, and then above the white bug, which is V2 plus 15, we actually set flap 1. And then we wait until we get to the flap 1 maneuvering speed and we set flap up. Again, guys, don't worry, because once we get there, I'll stop the simulator and I'll talk to you about that. Okay, so then once we have flap up speed, okay, we're gonna start climb again. Okay, we're gonna climb at flap up speed, and then we monitor that the flaps are actually retracted. And once we have flaps up without any lights, or flap up no lights, we're gonna set the MCT, the maximum continuous thrust, guys. Look at this. Okay, later on in this page we're gonna have maximum continuous thrust. The maximum continuous thrust, guys, is, as it says, is the thrust that the engine can operate at that maximum for a continuous period of time. Okay, so because you cannot fly the plane with a takeoff thrust forever. Okay, you only have a span a time of 5 minutes. After 5 minutes, you really need to set the maximum continuous thrust, which is the maximum thrust that the aircraft, the engine can operate forever, basically. Okay, as long as it has got some fuel on board. Okay, beautiful. And then once we have 1000 feet, we retract the flaps, we climb to up speed, we've got the flaps up on lights, we select level change, we select maximum continuous thrust, and then we basically select the autopilot. Okay, then once we engage the autopilot, we level off, and then from there we do the non-normal checks, but we are not going to perform the normal checks today. We are ready for takeoff. We've got around 7 tons of fuel, we cleared them, we've got flap 5, everything is in there. So guys, if you are happy, and just the last thing before takeoff, guys, okay, we are going to perform this flight without any flight directors nor auto throttle, so it's going to be manual flights. Okay, we are going to engage the autopilot, so once we retract the flaps and everything is fine, we're gonna switch on the flight directors, we're gonna switch on the roll mode, we're gonna basically set level change, and then the command A. Okay, we're gonna engage the autopilot and all the roll and pitch and roll modes later, once we've got the flaps up and we are climbing to the 3000 feet. Okay, so beautiful. So now that we are ready, we set time in there 40%, stabilized, and is set 93.8. Takeoff thrust sets, indications normal.
80 knots.
Check.
E1. E1. Rotate. Positive rate.
Gear up. Okay guys, let me stop the simulator here. Okay, so look at this situation here. We've got a little bit more than 12.5 degrees, okay, and we have to follow the V2 to V2 plus 20. I might follow slightly faster in order not to go down these red boxes, okay? But anyway, we've got 12.5 degrees, a little bit more, okay? We just retract the flaps and look at the engine number 1, okay guys? So the engine number 1, okay, is failed, okay? Because we've got engine failure alert in there. Look at the N1 rotation compared to the N1 rotation on the engine number 2, okay? We've got 94% on the engine number 2 and only 11% in there, okay? So definitely this is the problem, okay? The engine number 1 has failed, okay? So now we continue, we carry on, guys, and then we go to the 400 feet, which is our next target. The 400 feet normally is the, you see this yellow line there. Once this yellow line ends, pretty much where the 400 feet are, okay? And in there, we're gonna call the roll mode. In this case, it's going to be heading select, and we're gonna identify the problem, okay? In this case, we will identify the problem, all right? So now let's carry on. And what is it is important, guys, before before continuing, is that now we need to maintain the runway track with the rudder and wings level. So we need to really, the pilot flying is focused on flying the plane, okay? It's really focused on maintaining this center line there, this dashed white line. You see this dashed white line? This is the target, okay? The pilot flying is constant. You see, I'm going slightly to the left. So the first thing that I'm gonna do, I'm gonna turn slightly to the right again, in order to continue on this white line, okay, and follow the runway center line, basically. All right, so the pilot flying is focused on flying the plane, and the pilot monitoring is focused on make sure that the pilot flying is flying correctly, but on top of that, that all the systems are okay. So it's gonna, for example, now you see we've got this master caution, we can actually reset that because we will identify the failure later, and then it's actually making sure that all the systems are okay, and that's the problem, okay, that we've got the engine failure. So let's carry on. Check, heading select, identify the failure. Okay guys, as we said, okay, so now let's stop again the simulator. 400, I said heading select, but we didn't do anything because we are flying without any flight directors, and we identify the failure. So the pilot monitoring, so let's do like this, okay? So the pilot monitoring, in the case of the first officer, in this case, is gonna say something like that, okay? Engine number 1. Okay, because we've got the problem on engine number 1. N1 rotation, engine fail alert on AGT, N2 rotation, low fuel flow, and then it's gonna go down and check that we've got no fire indication or overheat indication. So in this case, we've got engine number 1, engine failure. So since there is no memory items for the engine number 1 engine failure, we continue and we climb to the 1000 feet above aerodrome level before the acceleration. Okay, and this, guys, is important because you need to identify the fact that you need to identify the failure correctly is extremely important, because if you do the wrong identification of the problem, you might apply the wrong checklist and the wrong memory items, because depending on the failure, you have to perform memory items that are procedure that has to be done by memory. Okay, and this procedure should be accomplished after 400 feet. But in this case, since the engine failure doesn't have any memory items, we don't touch anything. But there is another situation, for example, the engine fire that has got memory items, and if you have an engine fire, you, after 400 feet and after you identify the failure, you should perform the memory items for the engine fire. Okay, so, but as we said, engine failure, no memory items, we continue straight ahead, okay, and we call ATC and we send a pam pam message. Okay, so let's carry on. Next target, guys, is the 1000 feet acceleration. Okay, so now we call ATC. So the pilot monitor in this case is gonna call ATC and says something like that: pam 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 pam, pilot climb 001, engine failure, continue straight ahead 3000 feet, standby. Okay, and now you should always cross check and make sure you climb at a speed around V2. Okay, should be V2 and V2 plus 20, something like that. Okay,
1000.
so now, guys, 1000, we pitch down and we set the bug to the up speed. Okay, so up speed in there, I set the bug to the up speed. Okay, and we pitch down. Now above the white bug we can set flap 1, so I go flap 1. And it is very important, guys, that in this sector you prioritize the acceleration. So I'm trying to keep the vertical speed between 0 and 200 feet. Okay, very low vertical speed, because I'm trying to accelerate the fastest possible. Okay, now above flap 1 speed we can actually set flap up, and I still try to accelerate as fast as possible. And then once I've got the up speed, I climb with the up speed. So now we've got the up speed, I pitch up and I follow the up speed for the climb. Okay, and in the meantime, guys, as you can see there on the right, we've got the flaps up, no light. So let me stop the simulator again. And guys, now we've got the up speed a little bit faster than up speed, so I need to pitch up a little bit more. But very important is this, that we've got flaps up, no lights. Okay, so now you can actually set level change. You should set the maximum continuous thrust, and we set that in a second, because now we are still on the takeoff. Okay, so we need to have here continuous, set the maximum continuous thrust, and then we can engage the autopilot. Okay, so let's try to do that. Okay, so we've got flaps up, no lights. Okay, I continue climb with up speed. Okay, and then in this case let's now engage the autopilot. So we're gonna go heading select, level change. Okay, so now we go level change, maximum continuous thrust. Try always to follow as well the aircraft, which is not very easy. Performance, all right, so N1 limit, continuous. Look, guys, let me stop the simulator again. Okay, forget about this for a second, we fix it in a second, but because I'm alone here, guys, it's quite difficult to do all the things together. So guys, look at this. Now we're gonna set the continuous, this one, continuous, and it's gonna go here, like in this case, continuous. The maximum continuous thrust is 97.1, so it is even higher than the takeoff the takeoff thrust that we had before. So we can actually add some thrust and have extra power for our climb. Okay, beautiful. So now, since continuous is 97.1, we're gonna add some thrust on the engine number 1. Okay, and we climb, we keep climbing, we try to go back on the speed. Check. Level change didn't work in there. Here we go, I'll try again. And we should climb with the up speed. Okay, so guys, here is a small mistake, because you should keep up speed. Okay, I try to increase my pitch. Here we go. So now everything is fine. We can actually arm autopilot A, and the autopilot is gonna level off. Auto acquired, alt hold. So now we reduce the thrust a little bit, guys, and we back speed to 220 to have some margin. Okay, here we go. Beautiful. So now, guys, we are level off at 3000 feet with one engine out and 220 knots, 230. Let's go back to 220. one thing that you should do as well that really helps you out throughout your climb is this: to check your rudder trim. Now is still 0 because I was super busy explaining all the things, okay? And let me stop the simulator. So another thing that you should do during the climb is to apply some rudder trim. Now it's 0 because I was extremely busy doing the things, but throughout the climb, when you are climbing, you can actually put your hands in here and apply some rudder, okay? Some rudder trim. What rudder trim you apply? So you will see that the engine number 2, guys, the engine number 2 is the engine that is actually working. So you have a yaw moment to the left because the engine number 2 is pushing the aircraft to the left, okay? So you are applying the right pedal, okay? So if you want to have some help, you go and apply some right rudder. So you actually apply the rudder in the direction of the pedal that you are pushing. Okay, so let's do it. Okay, normally 3-4 units is okay. Okay, 3-4 units, something like that, and that should help as well the aircraft to have, instead of you putting all the pressure on the pedal with the rudder trim, that's gonna ease your the pressure on your feet. Okay, because on your foot, because after a long time pushing the pedal is gonna be quite tough. Okay, beautiful, guys. Now we are in this situation, we level off, okay, we are with one engine operative, okay, we just performed the profile for the climb. Now the first thing that you want to do is the non-normal checklist, okay? So now you basically, the pilot flying, we look at the pilot monitoring, and we ask for the non-normal checklist, okay? And the non-normal checklist should be the normal checklist applicable to this situation. In this case, we've got the engine failure, the engine has failed, okay? It's not severe damage because we still have some rotation in 1, we still have some rotation in 2, okay? We have some fuel flow, we don't have any fire on or any overheat indication, so you want to call the engine failure non-normal checklist. Okay, so what happens is that the pilot flying will still fly the plane, the pilot monitoring will take the QRH and start to perform the engine failure non-normal checklist. After the non-normal checklist, you perform the after takeoff checklist, okay? So the normal after takeoff checklist, okay, the one that is on the yoke, okay? And then like this, okay, the after takeoff checks, okay? So you don't touch the plane, you don't do the normal after takeoff checklist until the non-normal checklist is complete, because the non-normal checklist is a lot more important than the normal checklist, okay, for sure. So after that, the normal checklist complete and the normal checklist complete, you want to see what are you going to do. So you make a discussion with your colleague, your pilot monitor, your first officer, your captain, about what are the next course of action, okay? So first of all, the most important thing, guys, is to check if you can come back or you have to continue. If you can come back, because you're not gonna fly around with one engine operative, okay? So if you can come back, that means that the runway is long enough, the performance are good enough, the aircraft is suitable for that particular approach. In that case, you can come back. Okay, so normally it's always better to come back, especially if you took off from a maintenance base or something like that, or if you cannot come back because maybe the crosswind is above the limitation for landing, or you have cut 3 or the visibility is below your minimum with one engine operative, you have to continue. So what happens is that you basically plan and you just find out where you can actually go. Okay, you just try to get the weather for the nearest suitable airport and check what is the best option in there. Okay, so you continue, you check the fuel, you do all the preparation that is specified on the QRH, but we are not going to perform the QRH today. And then once everything is done, you know what you're doing, you know where are you going, you know what's your fuel, and you know what's the time. I mean, you know when you have to land, you call the cabin crew and you tell them, okay, you inform the cabin crew, and then once you inform the cabin crew, you inform as well the passengers, okay, and then you continue, all right, and then you perform the one engine operative landing checklist and so on, and you land with one engine operative. But that is a material for a separate video. Okay, so guys, I hope you enjoyed this video. I hope you understood a little bit more how to deal with the one engine operative takeoff. If you have any question, leave a comment below, and then also go to PILOTCLIMB.com where you can subscribe for free pilot training content. I wish you a great day, and I'll see you on the next one. Check, we can set to 70, please.